The vast expanse of the sky has always captivated humanity. Long before humans, pterosaurs claimed the skies. They were the first vertebrates to achieve powered flight. Their story is one of innovation and loss. Their reign ended, leaving fossilized remains. Centuries later, Stephen Hawking gazed at the heavens. He explored black holes and the universe. His work changed our perception of space and time. Both left legacies that compel us to look up. Pterosaurs hold a unique place in the history of life on Earth. They were the very first vertebrates to achieve true powered flight. This was a monumental evolutionary leap. Before them, insects had conquered the air, but pterosaurs were different. They were reptiles related to dinosaurs and crocodiles. Their wings were formed by a membrane of skin and muscle. This membrane stretched from an incredibly elongated fourth finger all the way to their ankles or body. This anatomical marvel allowed them to generate lift and propel themselves through the prehistoric skies. Their bones were hollow and lightweight, yet strong. They possessed a large sternum, or breastbone, for the attachment of powerful flight muscles. Their brains were also adapted for flight, with well-developed regions for balance and coordination. These flying reptiles first appeared in the fossil record during the late Triassic period, around 228 million years ago. For over 160 million years, they were a dominant presence in the skies. They were not clumsy gliders, they were active, flapping flyers. The significance of pterosaurs as the first flying vertebrates cannot be overstated. Their mastery of the air was a remarkable chapter in Earth's history. Throughout their long existence, pterosaurs evolved into a stunning array of forms. They were not a monolithic group of identical creatures. Instead, they displayed incredible diversity in size, shape, and lifestyle. The earliest pterosaurs, often referred to as rhamphorhynchoids, were generally smaller. Many had long tails, often ending in a vein-like structure that likely aided in steering. They also possessed teeth, suggesting a diet that included insects or small fish. As the Mesozoic era progressed, particularly into the Jurassic and Cretaceous periods, a new group of pterosaurs emerged, the pterodactyloids. These forms were generally more advanced. They typically had much shorter tails or no tails at all. Many pterodactyloids also lost their teeth, developing beaks similar to modern birds. This group included some of the largest flying creatures ever to exist. The dietary habits of pterosaurs were as varied as their physical forms. Pterosaur fossils have been discovered on every continent, including Antarctica. The reign of the pterosaurs, along with that of the non-avian dinosaurs, came to an abrupt and catastrophic end approximately 66 million years ago. The primary cause of this mass extinction is now widely accepted to be the impact of a massive asteroid or comet. This celestial body, estimated to be about 10 to 15 kilometers in diameter, slammed into the Earth in the region of what is now the Yucatan Peninsula in Mexico. The impact site is known as the Chicxulub crater. The immediate effects of the Chicxulub impact were devastating on a global scale. The energy released was equivalent to billions of atomic bombs. It would have triggered colossal earthquakes, unimaginable tsunamis, and widespread volcanic activity. Material ejected from the crater, including superheated rock and dust, rained back down upon the Earth. This caused global wildfires, incinerating vast swathes of vegetation. The sky would have turned dark as dust and soot filled the atmosphere, blocking out sunlight for months, possibly even years. This impact winter led to a dramatic drop in global temperatures and a collapse of photosynthetic processes. The extinction of the pterosaurs, alongside the non-avian dinosaurs and many other species, marked a profound turning point in the history of life on Earth. The world that emerged from the darkness of the impact winter was vastly different. The once dominant large reptiles were gone, leaving numerous ecological niches vacant. This created opportunities for the survivors, particularly mammals and birds. The skies, once patrolled by giant ajdarchids and agile anurognathids, were now open territory. This void was a crucial factor in the subsequent evolutionary radiation of birds, which diversified rapidly in the Paleogene period. The loss of pterosaurs meant the end of a unique evolutionary experiment in vertebrate flight. Birds, with their feathered wings derived from the entire forelimb, became the new masters of the air. The absence of large flying reptiles fundamentally altered aerial ecosystems. The types of predation from the sky changed, and the competition for aerial resources shifted. It is a stark reminder of how extinction events can reshape the biosphere. Centuries after the last pterosaur vanished, a mind of extraordinary brilliance emerged to explore the skies in a different way. Stephen William Hawking was born in Oxford, England on January 8, 1942. From a young age, he showed a keen interest in science and the universe. He pursued his higher education at University College, Oxford, and then at Trinity Hall, Cambridge, where he began his doctoral research in cosmology. It was during his time at Cambridge, at the age of 21, that he was diagnosed with amyotrophic lateral sclerosis, or ALS, a progressive neurodegenerative disease. Despite this devastating prognosis, Hawking refused to let his physical limitations define him or curtail his intellectual ambitions. As his body gradually failed him, his mind continued to soar. He became one of the most renowned theoretical physicists since Albert Einstein. His work focused on the fundamental laws that govern the universe. His resilience in the face of immense personal challenges was as remarkable as his scientific intellect. Stephen Hawking's most significant contributions to science revolved around the enigmatic objects known as black holes. In the early 1970s, working with Roger Penrose, he applied the mathematics of general relativity to show that black holes must contain a singularity, a point of infinite density where the known laws of physics break down. This work provided a robust theoretical framework for understanding these cosmic behemoths, which are formed from the collapse of massive stars. Perhaps his most famous discovery was that black holes are not entirely black. He demonstrated by combining principles of general relativity with quantum mechanics that black holes should emit a faint thermal radiation, now known as Hawking radiation. This was a revolutionary concept because classical physics predicted that nothing, not even light, could escape a black hole's gravitational pull once it crossed the event horizon. Hawking radiation implies that black holes can slowly lose mass and energy and eventually evaporate over vast timescales. This idea had profound implications for understanding the interplay between gravity and quantum effects. Beyond black holes, Hawking also made significant contributions to cosmology, the study of the origin and evolution of the universe. His work on the Big Bang theory helped to refine our understanding of the universe's earliest moments. Stephen Hawking's impact extended far beyond the realm of theoretical physics. He became a powerful advocate for science education and the importance of scientific literacy in society. He believed passionately in the human quest for knowledge and encouraged people, especially the young, to ask questions about the universe and our place within it. He often spoke about the need for continued investment in scientific research, emphasizing its role in solving global challenges and expanding human understanding. His own life was a powerful example of how curiosity and a drive to learn could lead to extraordinary achievements. Furthermore, Hawking was an inspirational figure for disability rights and for people living with disabilities worldwide. He never allowed his physical condition to define his potential or limit his aspirations. By living a full and incredibly productive life, he challenged societal perceptions of disability. He demonstrated that physical limitations do not have to be barriers to intellectual achievement or a meaningful existence. His visibility and his refusal to be sidelined provided hope and encouragement to countless individuals facing their own adversities. The skies have witnessed incredible stories. Millions of years ago, they were the domain of pterosaurs, pioneers of vertebrate flight. These creatures, with their skin-stretched wings, demonstrated life's remarkable capacity for innovation, conquering a new dimension. Their diverse forms, from small insect hunters to gigantic soarers, filled the Mesozoic air for an immense period. Their sudden extinction, a consequence of a cosmic catastrophe, reminds us of the fragility of even the most successful life forms. In more recent times, the skies, and indeed the entire cosmos, were explored by the extraordinary mind of Stephen Hawking. Confined to a wheelchair, his intellect roamed free, grappling with the most profound questions of existence. He unveiled secrets of black holes, pondered the universe's origins, and brought the wonders of cosmology to millions. His life was a testament to the power of human curiosity and resilience. Like the pterosaurs, he pushed boundaries not of physical flight, but of human understanding.